Hi there, this is Eric Keller for Otoy. In this video, we'll be taking a look at a brief overview of the Octane integration into Unity, and we'll be using this scene to demonstrate some of the features that allow us to render our Unity project with physically accurate lighting and shading. So let's start by taking a look at the scene. So it's a fairly simple scene. We have our spaceship here that's kind of in the configuration of the Octane logo, and it's kind of in an open space above the Unity logo here. So the first thing we need to do is make sure that Octane is loaded. So to make installing Octane easy, we've created this installer scene, which you can download, and you can import it into an empty Unity project, and in doing so, that will install the Octane integration. Once it's installed, we need, of course, to load it into the project. So I'll go to the Octane window up here and open up the settings, and up here in the corner, in the upper left-hand corner, I'm going to press the Load Octane button. That will load the integration. And this window contains other information, including license information, as well as the number of GPUs that are being utilized for rendering, and also some additional information on baking here at the bottom. But we can close this now that Octane is loaded. And the next thing I want to do is I need to go into the hierarchy here, and in this scene we've included a PBR render target. So I'm going to select the PBR render target and open up the inspector, and in the inspector I'm going to press the render button. When I do this, this will automatically open up the PBR viewport. It'll take a few moments to compile the scene, but once it's compiled, you can see here's the results. We have our nice Octane spaceship here over a reflective plane with the Unity logo and some physically accurate daylight rendering. It's a fairly simple scene, and we can obviously make it much more complex, but this is a great scene for getting yourself started and used to using the integration. So the next thing I want to do is take a look at some of the settings within the PBR render target. So I'm going to select the PBR render target here and take a look within the inspector, and you can see we have a lot of settings here beyond just the render button. For example, we can switch the camera. Currently, this scene is being rendered through our camera that we've set up to have this specific view. So when I select the camera, you can see here it is in the preview, and here it is in the render. I'll select the PBR render target, expand the camera settings, and let's set this, instead of custom, let's set this to the editor so that it matches what we see here in the editor. And so now you can see if I start to change the view of the editor, the OctaneRender updates accordingly as well. It's the same thing with the camera, but I kind of like that camera view, so I don't want to change it just yet. We can just kind of examine the scene through the editor camera as well. So let's also take a look at how we can adjust kind of the quality of the render that we're seeing in the PBR viewport. Let's get something like that. That works pretty well for now. Move this off to the side. You can also, I might take this tab here. Sometimes it's nice to stick the tab down here and then expand the view. That works pretty well. Just to highlight a couple things in the scene, you see this sort of ring right here. This is a reflection of this incandescent object that we have up here that's kind of sort of a ring light that I've added into the scene. And that's, of course, this is our sunlight in the distance. So if you're wondering what those are, that's just part of the lighting of the scene. Let's do something like this. That works pretty well. Okay, so I'll select the PBR render target, and let's close the camera folder for a moment. Let's go down to the film settings. This is where we can set the resolution of the scene. So you can see right now the resolution is actually quite high. So I have it set to 3000 by 1500, which is much bigger than we actually need. So what I'm going to do is I'm going to turn on lock aspect ratio, and let's set this to something a little bit more reasonable for our purposes. I'm going to set this to 1280 by 640, and also speed up the render a little bit too. So we can set the resolution using these settings. We can also go down to the kernel, which is kind of the master control for the quality and how the lighting is actually calculated. And we have several different kernels that we can use for rendering the scene. Right now I currently have path tracing, which is a physically accurate way to render things like reflections and refractions and also the interaction of light within the scene. If I set this to direct lighting, we'll get something that renders a bit faster. It's a bit more like a brute force method of rendering, so it's faster but not quite as physically accurate, A lot of times when I'm working on a project, I'll start rendering using the direct lighting kernel to get everything set up so I have a basic idea of how the lighting works. And then when I want to start to fine tune aspects like refraction and reflection and other effects, I will switch to either the path tracing kernel or the PMC. So these kind of go up in quality. So direct lighting is the basic rendering, path tracing is higher quality, more physically accurate, and PMC is the most physically accurate, but also takes a bit longer to render than the other two. We also have the info channels kernel, which is very useful for diagnosing various elements of the scene or how Octane sees the scene while we're rendering. So we have the choice between wireframe. We can also set up, say, Z depth, so we can render Z depth. If I set this to Z depth, I want to go down here to the slider and maybe increase this so we can kind of determine the depth within the scene. You can see it updates fairly quickly. We can also turn on things like geometric normal rendering, as well as many other different ways to view the scene. Ambient occlusion is also nice if you're working with a fairly large scene because it renders nice and quickly, as you can see when I start to move the scene around. And I can go down here to the AO distance and increase this so we can see it a little bit better. That works a little bit better. So let's switch back to the path tracing kernel. And I want to talk a little bit about the max sample settings. This determines the quality of the render. So the max sample settings, this sets the ceiling for the number of samples that will be calculated as Octane is rendering. So as we increase this, we'll see less noise in the render and many of the shading and lighting effects will become more resolved as well. So really the ideal max sample settings depends on your scene. So this scene looks pretty good at a setting of just 500, but we can increase this to say 2400 if we have a more complex scene or more complex shaders and that kind of thing. So as you can see, as I increase this, we'll see that this will start rendering, and you can see down here in the lower left, the 652 out of 2400 is just the number of samples that are currently rendered, and then this is the max ceiling. So you'll see this number will continue to increase until this number is reached. Now, a lot of these settings will help you kind of set various different amounts of depth to diffuse lighting bounces and specular depth and so on, and these can be tuned to improve the render and lower the render time as well. And those will be covered more in depth in a later guide, but I just want to point out where they are in the PBR render target window. Another feature I'd like to highlight is the render passes, and that is found within the PBR render target as well. I'm going to close the kernel folder here for a second and expand render passes, and we can activate a few of these, as many as we'd like. So let's just experiment. I'm going to turn on diffuse direct, diffuse indirect, reflection direct, and reflection indirect. And let's go down to the info passes. I'll turn on Z depth. We have our Z depth slider here, just like we had before in the render kernel settings. It does the same kind of thing. And we can also turn on, say, object ID, and I'm just kind of picking these at random, ambient occlusion, and we have our AO distance slider right here. So let's set this to, I don't know, something like 40 is fine. And as we activate these options here for the various render passes, we can view them by going to the PBR viewport and choosing this menu right here. So currently it's set to main by default, but if I open this menu, you can see here are the same render passes that I just activated. So I can switch between these, and while it's rendering in Octane, we can examine the various different render passes. And this is great, especially if you want to tune, say, specifically just the specular reflections. You can set the render pass to reflection direct or indirect, and then tune your shader and see the results in real time, which is really nice. So we can go in here, maybe increase the Z depth as well, using that slider. And of course we have object ID and ambient occlusion and essentially any of the passes that you want to activate here. And there's a lot of them. And if we want to save these out, we have a choice of saving the individual frame. So I can click on this icon right here that saves the current frame to disk. So this would save that AO pass as either 8 or 16-bit PNGs, or 8 or 16-bit EXRs, either tone mapped or untone mapped. If we want to just save all the passes in one go, we can click on this icon right here, which opens a dialog that allows us to choose the passes that we want to export, as well as some compression settings, so you don't have to save each individual frame one at a time, which is very nice. If we want to adjust things like the exposure or the color correction of the image, we can go down here to the imager settings within the PBR render target. We have a setting for exposure and color response. I have this set to off, but we also have several presets available that you can use. Set this back to off, and of course gamma, white point, vignetting, and saturation, and so on. Hot pixel removal can be used to remove fireflies. This scene doesn't really suffer from too many fireflies, but if you do have that problem, the lower this setting, the more fireflies will be removed. You have to be careful, depending on the scene, this could add a little bit of blurring, so you'll need to adjust this accordingly depending on your scene. And below this, we have post-processing effects. So if I go down here and enable the post-processing, we can add things like light bloom and glare. And this is great if you wanted to add things like glare rays and that kind of thing. So we can adjust the number of glare rays, the rotation, and blurring, and also we have spectral intensity. If I set this to 0, it's not going to shift the colors, but if I increase this, it will shift them depending on the value I put for the spectral shift. If you wanted to render out the post-process effects separately, you could go up to the render passes, and post-processing is available as a render pass. So if I turn this on, I can go over here to the PBR viewport and turn on, say, post-processing and render this out, and then composite it on top of my image using a program such as Nuke or After Effects. So far we've been rendering the scene using what's known as a thin lens camera, which is essentially like a movie camera. If we go back to the camera settings, you'll see that we can switch from thin lens camera to panoramic camera, which is great, especially if you're rendering something for VR. So we have a spherical projection, and we have a number of options for different types of cube maps or spherical maps or cylindrical maps, depending on what you need. And then of course we also can turn on stereo output. So if we put on something like over under, you can see now we're rendering out stereo images, which is great for rendering VR. And of course we have presets for whatever VR arrangement you might need to use for whatever your project demands. Set this back to thin lens camera. And let's talk a little bit about working with materials. So I'm going to go into the project window here. Let's take this tab and actually let's put it up here so we can see the materials. So, and I'm going to move this a little bit. So let's take a quick look at working with materials and Octane in Unity. So I'm going to right click here in the Octane installer scene folder and just choose create material. And let's just call this test. And I'm going to drag this material onto the ground here in our scene. You can see it updates within the Octane window. Now this is a standard Unity material, so if I go back to the inspector for this material, you can use standard and standard specular setup materials and render with Octane just fine. And if I wanted to add, say, a texture map, I could click on the albedo right here, open up the textures for this particular project, and you can see that it renders textures just fine using standard Unity materials. If, however, I want to use a more advanced material, such as an Octane material, I'll set the shader to Octane PBR override. And you won't see a whole lot of settings right here because we'll be doing most of our work within the Octane node editor. One thing you can do, though, is let's say we wanted to display a particular texture within the Unity scene. I can click on this icon right here, pull up our texture view. Let's select that diffuse texture again. We'll see it in the Unity scene, but it won't affect the Octane render. In order to affect the Octane render, let's add a few more textures using this Add Texture button. So this can be used to add textures that are linked to from within your Unity project. So if I click on this, now I can add some textures. I'll add this one. I'll click on this button. Let's add the dirty metal texture. And you can see as I'm doing this, it's listing the textures right there. So I'll click on one more. And just for fun, let's do this metal scratch. Now I've added these textures. It doesn't seem to affect very much here in the OctaneRender or in the Unity scene. So the next thing I need to do is click on the View Source window, and this will pull up the Octane node editor. And you'll also see a duplicate of our OctaneRender up here, which will update as we work with the material. If I middle mouse button drag, you can see it changes the view, and I can use the scroll button to zoom out. We have the textures here that I added. When I clicked on these buttons right here, you'll see them down here in the node editor. It will also see material out. So the first thing we need to do is add an Octane material. So this right here is a connection between the node editor and what we see in our OctaneRender. So I'm going to right click and pull up the menu here and choose Materials, Glossy Material. And now what I can do is I can click on the circle at the bottom of Glossy Material and drag a wire to Material Out. Now this connects a glossy material to the material out in our Unity scene, and we can see it update here in the OctaneRender. And now I can do things like adjust the various attributes of this glossy material. So for instance, if I pull the color down, these various different sliders, I can change the color of the diffuse. I can change the specularity. Let's just scroll down here a little bit so you can see the effect. We can also move this off to the side. And we can also adjust things like the roughness, index of refraction, and so on. And the great thing about this is that you can use all the Octane materials that are available within Octane in your Unity scene. And of course, we can also connect up these textures. So for example, if I wanted to connect this dirty metal to the diffuse, I can do that. You'll see the update right here. And I can continue to do things like just for fun, let's put the metal scratch in the bump channel. I can adjust the strength of the bump by selecting this texture, going into the node inspector, and adjusting the power. And say we can put this Clay's diffuse into, say, I don't know, the roughness. If we want to take a look at some of the materials that are within this scene, I'm going to close this for a second. I'll select our spaceship here, part of our spaceship. Go into the outliner. Let's select one of the parts here. And you can see here's the inspector for this part of the spaceship. Down here at the bottom, you can see we have a connection to our UFO hull material, which is the material that's applied to most of the spaceship. And you can see all the textures that are connected here. If I choose View Source, we can see the node graph. I'll use the scroll wheel here. Let's expand this so we can see what's going on. And you can see we have a fairly complex material built out of several different Octane materials applied to our spaceship. So within the installer scene, of course, you can open this up and start taking a look at how these materials have been connected. And these are using all standard Octane techniques. So there's plenty of documentation on working with Octane materials online. Whether you're using Octane standalone or one of the many plugins for, say, Maya, Cinema 4D, or 3ds Max, the basics of how the material works is the same through all of those various different programs. So this is a good one to go in here and kind of take apart and experiment with and see how it affects the actual render on the spaceship there. And finally, the last thing I'd like to take a look at within this Unity project is this smoke object that you see here in the hierarchy. So I'm going to select this. And in the inspector, make sure it's turned on. You'll see a gray box appears here in the Unity scene. If I move this over to the side, you'll see in the OctaneRender, this gray box, whoops, moved it a little bit too far, is actually a placeholder for this smoke object. So let's press undo a couple times to move it back to its original position. So this is kind of set up to look like the spaceship is emitting this little smoky kind of trail down here. So this is essentially an Orbix file. An Orbix file is created in Octane standalone and exported in the Orbix format, and you can import them into your Unity scene using the Octane menu. So if I go into Octane and choose Import Orbix, I can bring it into the scene and place it, and use it to augment the renders that I create within my Unity project. And in this case, we're using a little puff of smoke that was created by a VDB and a volumetric shader so that it interacts with the light in a very realistic way. So it gets a really cool smoky effect down here. So I hope you've enjoyed this overview. I encourage you to take a look at the scene and take it apart, examine some of the techniques that we've used to set it up, and see how you can apply them in your own Unity projects.